Hello everyone, I am Anushka Singh, currently at Nitya Meenakshi Institute of Technology, pursuing my BE degree in Artificial Intelligence and Data Science. Today I am here to talk about a topic, green building and sustainable materials, which is guided by Maulia Madam. What is green building? Green buildings are structures designed to reduce the overall impact on the environment and human health by efficiently using energy, water, and other resources throughout a building's life cycle from design and construction to operation and maintenance. What is a green building? A green building is a structure that is environmentally responsible and efficient throughout its life cycle. Resources from site selection to design, construction, operation, maintenance, renovation, and demolition. Objectives of green building concept: reduce energy consumption without sacrificing the comfort levels. And what are green buildings? So green buildings aims to minimal the impact, structure designed to reduce environmental and health effects. Resource efficiency, which leads to using the energy, water, and maintain water throughout life cycle. Life cycle focus optimized from design through maintenance for sustainability. So green buildings require LEED certification. Certified buildings uses 30 to 50% energy compared to any other buildings. So reduce destruction of natural areas, habitats, biodiversity, and reduce soil loss. Reduce air and water pollution. This is what green buildings are. Why do we need green buildings? Buildings consume nearly 40% of global energy and contribute to around 30% of greenhouse gas emissions. Rapid urbanization is increasing demand for infrastructure. Green buildings help reduce the environmental footprint and promote sustainable development. They are crucial in mitigating climate change and adapting cities to be more resilient, including the infographic showing energy used by sectoral carbon emissions from buildings. So key features of a green building energy are efficiency, which means energy efficiency, reduce electricity used through design and materials, good placement of windows, proper roofing, and trees outside can reduce heat. So you need less air conditioning, use local styles suited to the climate. Example, in hot areas, buildings with thick walls and small windows stay cooler. In Bangalore, many green buildings have solar panels and trees placed on the west side to block harsh sunlight. Second, water conservation. It is very important key feature of a green building. Water efficiency, save water, reuse it, and don't waste. Install rainwater harvesting, reuse water from washing for gardens, and use low flow taps. Water is a limited resources. So the next key feature of a green building are sustainable materials. Use renewable, recycled, and eco-friendly materials. Don't just use cement and sand. You can use bamboo, recycled steel, or even waste materials like fly ash or foundry sand. So the next key feature is good air, indoor air quality, proper ventilation and non-toxic materials with air purifications and smart design, maximizing natural light, cross ventilation, orientation for solar gain. Daylighting, use of natural light to reduce dependency on artificial lighting. Cross ventilation, building layout that allows window to flow naturally. Some eco-friendly buildings use scrap wood for furniture or ceramic waste in concrete. It saves cost and avoids pollution. The next key feature is thermal mass, materials like concrete or stone that absorbs and slowly release heat. So the next is sustainable materials. Sustainable materials are very essential for building a green buildings. The first is earthen materials. Natural materials like clay, sand, and straw. They are biodegradable, have high thermal mass, and are non-toxic. Uses of earthen metals can be on walls, floors, and plasters, and they are low embodied energy, locally available, and reusable. So the second sustainable material is wood. It is renewable and biodegradable if sourced responsibly. So the uses of wood can be in structural framing, flooring, cladding. It stores carbon, recyclable and has low embodied energy. The third is bamboo, fast growing grass with high strength to weight ratio. It can be used in flooring, walls, scaffolding and structural frames. It grows quickly, minimal processing and is biodegradable. It means it doesn't harm to the environment. And the next one is a structural insulated panels, SIPs. Panels made of a foam core between two structural facings. It can be used for walls, roofs, and floors in modern buildings. It has high insulation value, reduces energy consumption. Mushroom-based packaging. Example, uh, designs create biodegradable packaging using the root structure of mushrooms. And recycled ocean plastics in fashion. Example, Adidas ballet shoes are made up from plastic waste collected from oceans. So, and the next is cork in interiors and fashion. Example, Plecker produces handbags, wallets, and accessories using cork. Recycled steel and aluminium in architecture. The Edge building in Amsterdam, one of the world's greenest office buildings, used recycled steel. Next one is organic cotton in textiles. So for cotton for clothing, grown without harmful pesticides. Real world examples of green buildings are the Edge Amsterdam, known as one of the greenest office buildings, uses solar energy, rainwater collection, smart lighting, and energy neutral and tech integrated materials. The second is Indira Paryavaran Bhavan, Delhi is India's first net zero energy government building. Features solar panels, efficient HVAC, passing cooling designs, and achieved LED platinum rating. Benefits of green buildings. Environmental benefit. Reduces carbon footprint, energy consumption and waste. Economical benefit would be lower electricity and water bills, long-term cost savings on maintenance and operations. And the social benefit would be healthier indoor environments lead to better well-being and productivity, improved occupant satisfaction and comfort. So, what are the challenges faced during green buildings? Higher initial costs, eco-friendly technologies, and materials can be more expensive upfront. Lack of awareness. Many builders and consumers are not informed about the benefits and the material accessibilities. In some areas, sustainable building materials are hard to source. So, the challenges for green building are high costs, regulatory hurdles, complex codes and policies. In technical challenges, design, construction, and performances issues. Market demand, like limited awareness and interest, are the very most challenges which are faced during building green buildings. So, the future of green buildings. Smart buildings and IoT, automated systems that monitor energy and water usage. Renewable integration, use of solar panels, wind turbines, and rainwater harvestings. There are government supports for future of green buildings like incentives, subsidies, and certifications like LEED, GRIHA to encourage green constructions. Energy efficiency and renewable will rely heavily on solar panels, wind turbines, and geothermal systems for power. Smart grids and energy storage system will manage and distribute energy efficiently. So these are the future aspects of green building. By using sustainable materials, energy efficiency, smart technologies, and health and wellness, by improving indoor environmental quality. Resilience and climate adaptation. Green buildings will be designed to withstand extreme weather and natural disasters. Focus on water conservation, passive cooling, heating, and biodiversity. It is cost efficiency and ROI. Green buildings are becoming more affordable due to innovation and incentives. Owners benefit from lower energy costs, higher property values, and improved occupant health. And it also leads to urban integration. Integration with green infrastructure like green roofs, vertical gardens, and urban farms. Green buildings will contribute to sustainable city planning and reduced urban island effect. Focus on health and well being. Designs will increasingly consider mental and physical health with better air quality, natural light, and biophilic elements. So green buildings will not just be about reducing environmental impact, but will evolve into smart, resilient, and people-centered spaces that redefine how we live and work. How we live and work. So let us summarize our presentation. So let us summarize our presentation. So green buildings are vital to address climate change, conserve resources, and promote healthier living spaces. Green buildings represent the future of sustainable development, offering a path to reduce environmental impact while enhancing the quality of life by integrating renewable energy, smart technologies, sustainable materials, and energy efficient systems. We can build smarter, healthier, and more resilient communities. The challenges that exist today, like cost and awareness, can be overcome through innovation, policy support, and increased collaboration. Green building is not just a trend, it's a necessary for a sustainable tomorrow. So the buildings of tomorrow must start today. Let's support and demand eco-friendly construction practices and build a greener future for all. Thank you.